In this lecture, we take an example of a matrix whose eigenvalues and eigenvectors should be obtained. So let us take one matrix of order 2 by 2. We will try to find out the eigenvalues and eigenvectors of this matrix. And in the next example, we'll take the matrix of order 3 by 3. We have to find the eigenvalues and eigenvectors of the matrix A is equal to 14 minus 10, 5 minus 1. So this is very clear that if you want to find out the eigenvalues and eigenvectors of a matrix, the matrix should be always a square matrix. The characteristic equation of A to calculate the value of lambda or eigenvalue is given by determinant of A minus lambda equal to 0. This is what? It is the general equation of eigenvalues. A minus lambda equal to 0, determinant of A minus lambda equal to 0. Or we can also use this shortcut method to find out the eigenvalues of the matrix. Let us take both the equations. In both the cases, we will get the same answer. So I will explain one by one. Let us first take the first equation, determinant of A minus lambda I equal to 0. A minus lambda I equal to 0. Here, what is the value of A? A is nothing but the matrix 14 minus 10, 5 minus 1 minus lambda times of 1, 0, 0, 1. Determinant of equal to 0, which is equal to, this is 14 minus lambda, 14 minus lambda minus 10, 5 minus 0 is 5, minus 1 minus lambda, which is equal to 0. This is the determinant, 2 by 2 determinant. Let us simplify it. This multiply by this minus this multiply by this, which implies 14 minus lambda into minus 1 minus lambda, this minus of 5 into minus 10, which is equal to 0. If we take minus side from this part, we get minus of 14 minus lambda into 1 plus lambda. This minus 5 into minus 10 will become plus 50, which is equal to 0. If we simplify, let us multiply this one. So minus of 14 plus 14 lambda minus lambda square plus 50 equal to 0. If we again simplify it, let us multiply this by minus sign. So plus 14 lambda minus lambda is plus 13 lambda, and if we multiply by minus sign, it will become minus 13 lambda. This minus and minus will become plus. So we are able to first write lambda square minus 13 lambda, and this plus 50 minus 14, which is equal to plus 36 equal to 0. So lambda square minus 13 lambda plus 36 equal to 0 is the eigen equation or characteristic equation of the given matrix A. So this is what? This is the general method to find out the eigen characteristic equation of the given matrix A. Now, so we have taken this method. Let me try to use this method where S1 is equal to, where what is S1? S1 is nothing but the sum of diagonal elements. So now here, what is the diagonal? This is 14 and minus 1. So 14 and minus 1 are diagonal element. So if we add 14 plus minus 1, which is equal to 13, and determinant of A is nothing but the determinant of A, which gives us 14 into minus 1 minus of 5 into minus 10. So minus 14 plus 50, which is equal to 36. If we substitute, hence, equation 1 becomes, after substituting the value of S1 and determinant of A, lambda square minus 13 lambda plus 36, which is equal to 0. So now we have already seen that if we use the first method using this method, we have already obtained the same equation, lambda square minus 313 lambda plus 36 equal to 0. If we are using the shortcut method, then also we are getting the same equation. So now we are able to use both the equations. Both methods are correct. It is up to us that which method we have to use. But now, definitely there is some benefit to use the method number 1 or method number 2. What is the benefit to use the method number 2? Right? So first method, we won't use this method. We won't use only, I will not use in my or any lectures about this method. I will only use this shortcut method. Why I will use? So let me discuss about it. Why we use the shortcut method. Okay. So now in both the cases, we are getting the same equation, lambda square minus 13 lambda plus 36 equal to 0. This is nothing but Eigen equation or characteristic equation of the given matrix. Now we have to find out the values of lambda by solving this quadratic equation. So here 1 into 36 is 36. So we factorize 36 in such a way that the sum should be 13 and multiplication should be 36. So now we can write down 1 into 36. It can be also written as 2 into 18. It can be also written as 3 into 12. It can be also written as 4 into 9. And that's enough. So now these are the factors of 36. So now we can use those factors whose sum is equal to 13. So now 1 plus 36 or 36 minus 1 is not 13. If we use the fourth condition, 4 into 9, which is 13. So we are breaking over here. 13 can be breaked into two parts, which is minus lambda and minus 9 lambda and minus 4 lambda. Lambda square, 13 lambda is breakdown into two parts. First part is minus lambda, 9 lambda, and second part is minus 4 lambda plus 36 equal to 0. Now from the first two part, if we take lambda outside, so lambda is remaining in the first term and 9 is remaining in the second term. In the second part, if we take minus 4 outside, so lambda is remaining in the first step, and if we take 4 outside, we have the 9 is remaining over here. Now since lambda minus 9 is common in both the part, we can take 9 lambda minus 9 outside. So here lambda is remaining and here 4 is remaining. So lambda minus 9 into lambda minus 4, which is equal to 0. And if we simplify it, we are getting lambda minus 9 equal to 0 or lambda minus 4 equal to 0. What it gives? It gives that the value of lambda is 4 and 9. Now let us check that this is the eigenvalues of the given matrix or not. So while discussing about the properties of eigenvalues and eigenvectors, we have already seen that if the eigenvalues of a given matrix and the trace of the given matrix both have some relation. What is that relation? That relation is nothing but what is the sum of the diagonal element? What is the sum of diagonal element? It is nothing but 13. And if we add the again, what is the sum of these eigenvalues? So 4 plus 9, which is also equal to 13. This is the first condition that if we are able to find out the eigenvalues of the given matrix, sum of the eigenvalues, which is 4 plus 9, which is equal to the sum of the diagonal element, which is 14 plus minus 1, which is equal to 13. Both should be same. The second condition, what is the multiplication of these eigenvalues? 4 into 9, which is equal to 36. So multiplication of these eigenvalues is 36. Now, what is the determinant of the given matrix? What is the determinant of the given matrix? It is again 36. So clearly, we have verified that this answer is correct. How to check it? So for this purpose, we have to use the property number 1, the sum of diagonal element, which is equal to the sum of eigenvalues. And the second thing is the value determinant of the given matrix, which is equal to the multiplication of the eigenvalues. And now that's why I am using the second method. Why I am using second method? Because if we use the second method, we are also find S1, we are also find determinant of A. If we are using the first method, so for checking our this method, we have to find out the sum of eigenvalues and sum and determinant of the given matrix. So this two jobs should be additional work while using the first method. So that's why we always use the second method, which is called shortcut method, to find out the eigenvalues of the given matrix. So now this is the first part of this question in which we have obtained the eigenvalues of the given matrix. Now the second part is remaining, which is which is which is we have to find out the eigenvectors of the given matrix. So let us try to find out how to find the let us take how to find the eigenvectors of the given matrix corresponding to eigenvalues. Now we have to find the eigenvectors corresponding to eigenvalues lambda equal to 4 and 9. Let us take the first eigenvector corresponding to eigenvalue lambda equal to 4. Let x1, which is equal to the column vector x1 x2 transpose, be eigenvector corresponding to the eigenvalue lambda equal to 4. Then the characteristic equation of A is given by A minus lambda I times of x, which is equal to 0. Here what is A? A is nothing but the given matrix 14 minus 10, 14 minus 10, 5 minus 1 minus lambda, and I is nothing but 1 0 0 1. And this x is what? X1, we can say that is x1 is x1 x2, which is equal to 0 0. Let us simplify it. We are not doing anything over here. We have to just multiplying 1 by lambda. 0 into lambda is 0. Lambda into 0 is 0. Lambda into 1 is 1. So lambda and lambda. Now if we subtract this matrix to this matrix, we are getting 14 minus lambda minus 10, 5, 5, and minus 1 minus lambda into x1 x2, which is equal to 0 0. So this is what we can say that this is the uh, characteristic equation to find out the eigenvectors. Now here, if we put lambda equal to 4, we are able to get what is the eigenvector corresponding to the eigenvalue lambda equal to 4. Let us put what is the value of lambda over here. Putting lambda equal to 4 in 4, we have 14 minus 4 minus 10, 5 minus 1 minus lambda 4 into x1 x2, which is equal to 0 0. 14 minus 4 is 10 minus 10, 5 minus 5, x1 x2, which is equal to 0 0. If we simplify it, if we just multiply it, 10 into x1 minus 10 into x2, which is equal to 0. And second is the 5 into x1 minus 5 into x2, which is equal to 0. And Again, we can write down. If we divide this or multiply this equation by 1 by 10, we get x1 minus x2 equal to 0. If we multiply this equation by 1 by 5, then also we get the x1 minus x2 equal to 0. Here, both the equations are same. 10x1 minus 10x2 equal to 0, 5x1 minus 5x2 equal to 0. Both are the same equation, which is what? X1 minus x2 equal to 0. Let us take x2 is equal to t. Then what is the value of x1? If you put this is t, then x1 is also equal to t. Here, therefore, the eigenvector corresponding to lambda equal to 4 is x1 equal to t transpose r, which is equal to 1 1 column vector 1 1, and we have taken t outside. So now I have already told that corresponding to one eigenvector lambda equal to 4, we are getting the infinitely many eigenvectors, right? Because if t is real number, so if you put t equal to 1 1, t is 1, we get the one eigenvalue vector. If you put t equal to 2, 3, 4, 5, so and so on. So we are getting, since we have the infinitely many real numbers, we are getting the infinitely many eigenvectors. Hence, the eigenvector corresponding to lambda equal to 4 is 1 1. Now let us take the second part, or eigenvector corresponding to lambda equal to 9. Eigenvector corresponding to eigenvalue lambda equal to 9. Let x2, which is equal to x1 x2 transpose, be eigenvector corresponding to the eigenvalue lambda equal to 9. Then putting lambda equal to 9 in equation number 4. So 14 minus lambda will become 14 minus 9, minus 1 minus lambda will become minus 1 minus 9. If we again simplify it, we are getting 5 minus 10, 14 minus 9 is 5, minus 10, 5 minus 1 minus 9 is minus 10. If we write down the in terms of equation, 5x1 minus 11x2 equal to 0, and 5x1 minus, 5x1 minus 10x2 equal to 0, and same equations we are getting 5x1 minus 10x2 equal to 0. So we have only one equation, x1 minus 2x2 equal to 0. Now here, if you put x2 equal to t, putting x2 equal to t, we are getting x1 equal to 2t. Hence, the eigenvector corresponding to lambda equal to 9 is x1 is equal to 2t transpose. And if we take t as a common, so least common value is 1. So we write down 2 1s. This is the eigenvector corresponding to lambda equal to 9. Hence, the eigenvalues and eigenvectors of the given matrix are given by lambda 1, which is equal to 4, and corresponding to this eigenvalue, eigenvector is 1 1. Similarly, corresponding to lambda equal to 2, the eigenvector is 2 1. So these are the eigenvalues and eigenvectors of the given matrix. Thank you.